Alright, let's have a look at this particular problem. This particular problem can be very tricky because of one of two reasons. One, there are lots of numbers everywhere, and some of these numbers can actually be a little bit irrelevant. And also, if you're not paying attention, and you're not paying attention to your system, to your direction, some of these numbers can also be off-putting. So first things first, like we always do, let's find my red pen. Let's define the direction. So let's define the positive direction as the direction of the landing plane. So the direction that the plane is landing. So down the runway. So now notice that this is going to be intuitive in a couple of seconds. You'll find this. So let's have a look at some of the more useful numbers in amongst this. So obviously 747, not useful, but Boeing 747s being able to carry more than 560 passengers, they're pretty big. That's a pretty big passenger aircraft. So let's have a look. We know that the max speed is 970 kilometers per hour, but that is not actually relevant. That's really off-putting, so just be careful with that one. So here is the actual useful stuff. The plane is actually starting its landing at 134 meters per second. So we know, and let's put that to yellow, that its initial velocity, u, is at 134 meters per second. And we also know that it has a constant acceleration. So the acceleration is green. Now notice here that the acceleration is negative. It's negative 4.8 meters per second per second. What does that mean? A negative acceleration in this particular example means that it is accelerating in the opposite direction that it is actually landing. So if it's landing down the runway, its acceleration is going away from the runway in the opposite direction. What does this mean to motion? If you have a negative acceleration, if your acceleration is going in the opposite direction, especially for one-dimensional problems, it means it is decelerating, meaning the velocity will be decreasing as time goes by. So in this particular example, the velocity will decrease 4.8 meters per second every second that time goes along. So, but for now, that is all we're really given. Oh no, sorry. There's one more term that we actually need to have, and that is your final velocity, your v term. So your v term is going to be 0, right? Because it wants to stop. You want to go from 134 meters per second. It starts landing, and then they chuck on the brakes, and it takes them however long to get to a standstill, to stop. So our final velocity is 0. So in this particular example, let's have a look at what Mr. Kuhn has. We will need to figure out, and let's put in blue, we need to figure out what time is. We don't know time in seconds. That is horrible. Time in seconds. Okay, so let's start with our equation. What equation are we going to use? We have v, we have u, we have a. We want to figure out t. So intuitively, v equals u plus a t. Very good. If we plug in our values, so our v, I'm just going to put it as 0. I'm not going to put in the units because it's going to end up being 0 anyway. I'll put in the units for the others though. Okay, u, we start off at 134 meters per second. Let's add that to, so let's add that to our acceleration. green, our acceleration is, let's get rid of this one, it should be, because our acceleration is going to be negative, we're going to need to not add that. It's going to end up being take away. So it'll be take away 4.8 meters per second multiplied by our time, which is, what's our time? Time is in blue. So let's go, time is in blue. So because our left hand side will be 0, what if we bring this over to the left hand side? If we bring that over to the left hand side, then we will get negative 134 meters per second will equal to negative, let's put that in green, negative 4.8 meters per second multiplied by t times t. Okay, and here, in order to get t, to solve for t, we just need to divide both sides by 4.8 meters per second. So let me put the numbers down first. So 134 divided, and then let me put the units, meters per second, and let me divide that by our acceleration. So divide that by, here is negative 134, right? Remember, negative 134. Divide that by negative 4.8. So whenever you divide a negative value by a negative value, you're going to get a positive value. So if we divide that by meters per second, okay, these two terms cancel out, and one of these two terms, so there's two of these, so this becomes a -1, this cancels, so this then comes up to the top, giving our final answer. Intuitively, time is in seconds. So Mr. Coombe, he plugged that in somewhere. Let me find it, sorry. So the time equals 27.92 seconds. Excellent. So now we have time. So now I have to scroll down a little bit more because there's two parts to this problem. So number 2, let's have a look at part number 2. We want to know what is the minimum distance of runway that is needed. So it took him 27.92, let me fix that up, that decimal point, 27.92 seconds to go from 134 meters per second to 0, to stop. So we now want to find out the displacement, and that is quite easy. Let's put displacement as magenta. So we want to find out displacement. We don't know that, and it's going to be meters. So our displacement, we're going to use red. Displacement equals ut plus half at squared. Now this particular expression here, this time, is going to be quite interesting, because obviously here you're going to have a negative acceleration, so the acceleration is going back the other way. So this won't be plus, it'll actually be minus. So let's solve it. What were we in magenta? So S would equal, our initial velocity was 134. Was there more? So what, 134? No, that's it. 134 meters per second. Multiply that by the time, which is 27.92 seconds. And then I'm going to put already, well, for now I'll put plus, just so it's a bit more intuitive. Plus half of our acceleration, which is negative, oh, we don't want white, we want green, of our negative 4.8 meters per second, multiplied by our time squared, which is multiplied by 27.92. If we square, if we square that, our seconds will also be squared. Okay, very good. So if we evaluate that, if we actually do what that actually is, Mr. Kim had it written down. This first part, the UT, would be 3,741.28 meters, because if you multiply second to the negative 1 and seconds, they essentially cancel out. So they're going to cancel out, and you end up, so it's not adding, because remember, if you're, let's halve that, so it'll be 2.4, so negative 2.4. So that'll be minus, and I'll put this part here as green, minus, so that'll be negative 2.4 meters per second if you multiply that by 27.92 squared, multiply that by second squared. So these two terms here, they cancel out. So this cancels out, that cancels out. So you're left with just meters, right? So then it's minus, it actually ends up minus 1,870.86 meters. And if you do that math, basic subtraction, it actually ends up 1,870.42 meters down the runway, so which is approximately 1.87 kilometers. So you need minimum 1.87 kilometers for your runway. So hopefully this was helpful for you guys. See you later.